Hey everybody, welcome to Chapter 4, Section 1, Classifying Triangles. In this video, we're going to classify triangles based on their sides or their angle measures, okay? So a couple of bullet points to go over at the top. All triangles will have at least two acute angles, whether it's an acute, equal angular, obtuse, or right angle. It will have at least two acute angles. The third angle is used to classify the triangle, okay? So by the third angle, I usually just look at the angle with the biggest measure, and I refer to that as the third angle, and that'll tell me whether it's one of these four. So in this example right here, example 1, we're going to classify these based on the angles. So here I have 70, 70, 40. So the biggest angle would be 70. So that's going to be an acute angle triangle. This is a 30, 60, 90. So the biggest angle right there is 90. And that's a right angle, making this a right triangle. So this one, 97, 49, 34. If the angle's bigger than 90, it is obtuse. If it's smaller than 90, it is acute. If it equals 90, it's right angle. So this is bigger than 90. That makes this an obtuse triangle. And then if they're all the exact same measure, that's equal angular. You'll have to double check me on this, but I think the alternate pronunciation of this word is equiangular. But it's, I'll generally just say equal angular. It sounds like equilateral. Equilateral means all sides are the same. Equal angular means equiangular means all angles are the same. And so if it's a triangle, they'll all be 60 because we'll talk about it more later, but all the angles inside of a triangle add up to 180. You might notice that about all these. If you added up all the angles inside of each triangle, they'd all add up to 180. Again, I'll talk more about that in future videos. But let's get to this image. So here I have a big triangle, and then I have two small triangles inside them. So I'm asking you about each one of those triangles. So PQS would be PQS, this one here. So this is 45, 45, and then we can gather that this one's 90 as well. So that means PQS is going to be a right angle triangle or a right triangle. Similarly, the triangle of SQR, it doesn't really matter what order the letters are in. SQR, the biggest angle will be 90, so that's also going to be a right triangle. So that leaves the last triangle of PQR. PQR, if you just trace the three letters, you'll know what triangle you're talking about. So PQR is this largest triangle here. So we have 45, 31, and then if you add these two together, that's going to make 90 plus 14, so that's going to be 104. So if that's 104, that's the largest angle. So that's going to be an obtuse angle triangle or an obtuse triangle. So that's pretty much all there is to that. So the next bank I'll go over is classifying triangles by their sides. And then here you have the aforementioned equilateral triangle where all three sides are the same. An isosceles triangle has two sides of the same length, and then a scalene triangle has no congruent sides. They're all different lengths. So right angle triangles are always going to be scalene. Equilateral triangles will always be equiangular or technically acute, but you don't say they're acute if it's all the same measure. It's equiangular. But this first one, you have two sides that are marked the same, so that's going to be isosceles. This one is 5, 12, 13. I know because of the side lengths, this is going to be a right angle triangle because of the Pythagorean theorem. 5 squared plus 12 squared equals 13 squared. Anyway, this is a scalene triangle. Again, scalene, all three sides are different. I just brought up the Pythagorean theorem just to kind of elaborate on the point I was trying to make earlier that right angle triangles are going to be scalene. So let's turn our attention to this hot mess of a triangle over here. Well, it's technically not a triangle because all four sides, or a triangle has three sides and this has four sides, but inside of it are a bunch of triangles. So triangle ABC is what we'll go over first. ABC, if you trace that here, you see that this dash mark and these with 2 dash marks indicate that those are 2 different side lengths, and then there's a 4 here. So if there's 3 different side lengths, that's basically what we can gather, then we're going to say that this is a scalene triangle. So next we'll turn our attention to ADF, AD, and then F is over here. So ADF. So we have, this says 8, and it's marked here, so this is going to be an 8. And so we have 8, 10, and then we don't know exactly what this is. This is going to be 5. And so I'm going to go ahead and gather that since this is a 4 here, this should probably be a 4 there. And then since this is a 5 over here, then it should probably be another 5 over there. So that makes this all a 10. And so if this goes 10, and this is 10, and this is 8, that makes ADF an isosceles triangle. So next we'll look at AED. So A here, AE, there, and then here's D. So we have different, different, different. So this is going to be another scalene triangle. Next is ACD. So A here, C there, D there. So this is going to be different than this. And so we don't know what this measure is, but this is 8, this is 4, so it's going to be all different again. So ACD is another scalene triangle. And lastly, we have ABD. So A, B to D. So 8, 8, what's 4 plus 4? 4 plus 4 is 8. So 8, 8, 8 means all 3 sides are the same. If all 3 sides are the same, it's equilateral. Okay? So now let's do a few solving examples. Here in example 3, I'm going to find x and the length of each side if RST is an equilateral triangle. So if it's equilateral, that means all 3 sides are equal to each other. So to solve this, you can pick any 2 sides and set them equal to one another. So I'll just pick these 2 sides. So setting 3x equal to 2x plus 2, I can minus 2x to the other side. 3x minus 2x is x. That makes x equal to 2. So if x equals 2, I'll plug those into rs and st and rt. They should all equal the same thing. That's how you know you did it right. So what's 2 times 2 plus 2? That's 4 plus 2. That's going to equal 6. So let's do st next. St equals 3 times 2, which is 6. And then let's do rt. So rt is 5 times 2. Make this say an equal sign there. 5 times 2 is 10. 10 minus 4 is 6. So yeah, we found out all the side measures, and they're all 6 when x equals 2. So yeah, that's it. Let's do example 4. So find x and the length of each side if triangle ABC is an isosceles triangle with AB equaling BC. So find AB. There you go. These 2 sides, and BC, so set these equal to one another. So with 4y equal to 3y plus 2 minus 3y to the other side, and 4y minus 3y is 1y, or just y. And so, hey, I get y equals 2, just like the last one with x equals 2. So, real original there, I guess. Let's find AB. And so AB is 4 times 2, so that's going to be 8. So BC should also be 8. So BC is going to be 3 times 2, that's 6. 6 plus 2 equals 8. So that's good. And then we're going to plug it into the last side, AC, which should be different from those 2. And we're going to do 3 times 2, and that's simply 6. So that's example 4. Let's move on to example 5. Example 5 says find x and the length of each side of triangle ABC is a scalene triangle. That means all sides are different, with the length of triangle ABC equals 32. So you might see length of the triangle. You might see the perimeter. Perimeters at all the sides added up. So if the perimeter of ABC is 32, so I'll write it down just to really drive it home. If it says length of the triangle, it'll say perimeter. I'm just going to change it actually. So with the perimeter of triangle ABC equal to 32. So that means add all these together and equal it to 32. So 2x minus 7 plus x minus 3 plus 4x minus 21 equals 32. So add all your like terms together. We have 2x plus x, that's 3x, plus 4x, that's 7x. And then we're going to combine minus 7, minus 3, that's minus 10, minus 21 makes minus 31, equal to 32. So then I will add 31 to the other side. 32 plus 31 is 63. So 7x equals 63. Divide both sides by 7, and you get 9. X equal to 9. So when I plug this back in, you should have 3 different answers. And then if you want to check your work, add them all back up, and they should equal 32. So AB is going to be 2 times 9, that's 18, minus 7, that's 11. Then BC is going to come next, and that's going to be 4 times 9, that's 36, minus 21, that leaves 15 behind. And then I have AC, which is just going to be 9 minus 3, which is 6. So if you want to check your work, what's 11 plus 15? That's going to make 26. What's 26 plus 6? That's 32. So you know you did it right that way. So that's going to draw these notes to a close. Thank you for watching, and goodbye.